Welcome to Copilot Podcasts. What if I told you that your coffee cup, your phone, even your own body, none of it is actually made of particles? That everything you think you know about matter is wrong, and reality is actually built from prime numbers carrying geometric information? Today, we're diving into Ontology II, a framework that claims the universe is literally a number-theoretic field where curvature and torsion generate everything from quantum mechanics to your morning commute. By the end of this episode, you'll understand how arithmetic becomes physics and why the author thinks we've been looking at reality completely backwards for centuries. Let me bring in someone who's actually worked through this dense mathematical framework.
So the core insight here is that we've been thinking about physics upside down. We assume particles exist and then try to explain their behavior. But this framework starts with pure arithmetic, the natural numbers and their properties, and shows how everything we call physics emerges from that substrate.
Wait, hold up. You're saying numbers literally become matter?
Not exactly. It's more like each prime number carries geometric data. It has curvature, torsion, a knot type, something called a refinement height. These properties determine what kind of particle it projects as in our observable world. So a proton isn't a fundamental thing, it's the shadow of specific prime numbers with specific geometric signatures.
This sounds completely insane, but let's dig in. What's this KT field they keep talking about?
KT stands for kappa tau, which are the curvature and torsion generators. Think of them as the two fundamental operations that create reality. Kappa is associated with space and torsion, tau is associated with time and curvature. Everything, and I mean everything, gets expressed as combinations of these two generators.
So like my coffee cup is some combination of K and T?
Exactly. Every physical quantity gets a dimensional type, like K to the power A, T to the power B. Mass is K cubed T to the negative 2. Length is just K, time is just T. It's like the universe has this underlying algebra where everything is built from these two basic operations.
Okay, but this is where I start getting lost. How do you get from abstract math to actual physics?
That's where the mod 4 structure comes in. The natural numbers get divided into classes based on their remainder when divided by 4. Numbers that are 1 mod 4 become the time rail, they generate temporal flow. Numbers that are 3 mod 4 become the space rail, they generate spatial structure.
So like the number 5 is 1 mod 4, so it's somehow connected to time?
Right, and 7 is 3 mod 4, so it's connected to space. But here's the wild part, this isn't just abstract classification. The framework claims this is literally how the universe generates time and space. The 1 mod 4 rail creates continuous temporal flow through what they call right hemisphere processing. The 3 mod 4 rail creates discrete spatial structure through left hemisphere processing.
Wait, they're bringing brain hemispheres into this?
Yeah, there's this whole section on how the right hemisphere generates time through continuous curvature increments, while the left hemisphere archives this as discrete spatial intervals. It's like consciousness and physics are two sides of the same arithmetic coin.
That's actually kind of beautiful in a weird way. But let's talk about something I can maybe wrap my head around. What about quantum mechanics?
This is where it gets really interesting. Quantum mechanics isn't fundamental, it's what they call the interior limit of the KT field. The Hilbert space, wave functions, all of that emerges when you take the continuum limit of something called the refinement space.
Refinement space?
Think of it like this. The universe starts with discrete countable refinement modes. Each mode corresponds to a specific geometric configuration. When you complete this space under a refinement invariant norm, you get the quantum Hilbert space. So superposition, interference, all the weird quantum stuff, it's just the continuum shadow of discrete geometric refinement.
So quantum weirdness is just math?
Well, geometric math. The Born rule, why probabilities are the square of amplitudes, that emerges as the unique refinement invariant measure. Quantum collapse is geometric factorization. Even the complex numbers in quantum mechanics aren't fundamental, they arise from refinement rotation in the interior.
Okay, but what about the thing that really blew my mind reading this, the Möbius boundary?
Oh man, this is the key to everything. The universe has these non-orientable boundary surfaces, Möbius strips basically, that enforce quantization. The reason energy levels are discrete isn't because of some quantum principle, it's because the universe has a twisted boundary that forces everything to satisfy certain periodicity constraints.
So like the universe literally has a Möbius strip built into it?
Multiple ones. There's a curvature boundary and a torsion boundary. Their global twist is what creates the discrete spectrum we see in quantum mechanics. It's not that particles have quantized energy, it's that the geometric boundary of reality forces everything to be quantized.
That's actually insane. And this explains why we can't have arbitrary energy levels?
Exactly. The Möbius boundary creates what they call refinement stable modes. Only certain geometric configurations can persist. Everything else gets filtered out by the boundary constraints. So quantization isn't a mystery, it's topology.
This is making my brain hurt in the best way. What about relativity? How does Einstein fit into this?
General relativity is what they call the exterior limit. It's what you see when you take the smooth continuum approximation of the KT field. The metric tensor isn't fundamental. It emerges as a refinement potential. Space-time curvature is just the continuum shadow of the discrete curvature torsion generators.
So Einstein was looking at shadows on the cave wall?
Kind of, yeah. The Einstein equations are compatibility conditions. They're what you get when the discrete curvature torsion evolution becomes smooth. But the real action is happening in the arithmetic substrate underneath.
Let me ask about something that really caught my attention. They talk about matter being minimum Gibbs-free energy endpoints. What does that mean?
So remember how each prime has geometric properties? Well, the universe is constantly trying to minimize its energy. It turns out that Gaussian primes in the complex plane, represent the deepest energy wells. Matter forms exactly at these locations because they're the most stable configurations.
So like iron 56 being super stable isn't just nuclear physics, it's because it sits in some optimal spot in this geometric landscape?
Exactly. The periodic table is basically a map of where the universe found its most stable geometric configurations. Each element corresponds to specific prime index refinement modes that minimize the KT Hamiltonian.
This is wild. But let's talk about something I can actually test. Do they make any predictions?
Oh yeah, tons. They predict a specific gravitational wave frequency at 10.208 megahertz from what they call the successor frequency. They predict the cosmic microwave background should show a 1.92 degree global rotation. They predict dark matter isn't particles, but geometric boundaries.
Wait, dark matter is geometry?
According to this, yeah. Dark matter is a curvature threshold, a boundary where space becomes too weakly curved to bind normal matter. So galaxy halos aren't made of particles, they're geometric phase transitions.
That would explain why we can't find dark matter particles.
Right. And they predict we never will, because there aren't any. They also predict that early galaxies should be way more massive than standard cosmology expects, which is exactly what JWST is finding.
Hold on, JWST is actually seeing things that support this framework?
The early massive galaxies, yeah. Standard cosmology says structure formation should be slow and hierarchical. But this framework predicts rapid saddle escape. The universe quickly falls into stable configurations. So you get massive, evolved galaxies much earlier than expected.
That's actually testable. What about the Hubble tension?
They predict it won't resolve. The difference between early and late Hubble measurements, about 5.6 kilometers per second per megaparsec, corresponds to their 1.92-degree phase shift. It's not a measurement error, it's a structural feature of how the universe works.
So if the Hubble tension gets resolved, this whole framework is wrong?
Exactly. That's what I like about this. It's actually falsifiable. If dark matter particles get discovered, if the CMB doesn't show the predicted rotation, if the gravitational wave peak isn't there, the whole thing falls apart.
Let me ask about something that seems almost philosophical. They spend a lot of time criticizing the cogito, I think, therefore I am. What's that about?
This is actually really deep. They argue that Descartes got it backwards. He started with thought, with representation, instead of with the generative mechanism that produces thought. It's like trying to understand a movie by analyzing the screen instead of the projector.
So consciousness isn't fundamental either?
It's the interference pattern between the two rails, the continuous time-generating rail and the discrete space archiving rail. Consciousness is what it feels like to be the intersection of these two arithmetic processes.
That's actually beautiful, but also terrifying. Are we just math?
We're geometric math. There's something about the curvature torsion structure that creates the experience of being. It's not reductive, it's showing that reality is way richer and more structured than we thought.
Let me ask about something practical. If this is all true, what does it mean for technology, for how we live?
Well, if you can manipulate the curvature torsion field directly, you might be able to do things that seem impossible now. Control gravity, create new forms of matter, maybe even engineer consciousness itself. But that's way beyond our current capabilities.
What about the tokamak stuff at the end? That seemed more immediate.
Oh yeah, the fusion reactor discussion. They're saying that controlling Lorentz force coherence, whether the magnetic forces are organized or turbulent, could be a new control parameter for fusion. If you can keep the forces coherent, you get heating. If they become turbulent, you maintain temperature.
So this could actually help solve the fusion energy problem?
Potentially. It's a different way of thinking about plasma control that current tokamak designs don't use. Whether it works in practice, that's an engineering question.
Okay, so stepping back, what's your overall take on this framework? Is it brilliant or completely insane?
Honestly, both. It's either the most important physics breakthrough in centuries, or it's an incredibly elaborate mathematical fantasy. But the fact that it makes specific, testable predictions means we'll know which one pretty soon.
What would convince you it's real?
If they find that gravitational wave peak at 10.208 megahertz, if the CMB rotation signature shows up in the data, if dark matter searches keep coming up empty while galaxy rotation curves show the predicted sharp boundaries, any one of those would be huge.
And what would convince you it's wrong?
If they discover dark matter particles, if the Hubble tension resolves, if the early galaxy anomalies turn out to be systematic errors. The framework is actually pretty vulnerable. There are lots of ways it could fail.
That's what I respect about it. It's not hiding behind unfalsifiable claims.
Exactly. Whether you buy the philosophy or not, the predictions are clear. The universe will answer.
So when you step back from all this, the arithmetic substrate, the Möbius boundaries, the curvature torsion generators, what does it really mean? If this framework is right, how should we think about reality differently?
I think it means reality is way more structured and purposeful than we assumed. Instead of particles bumping around randomly, we have this elegant arithmetic engine generating everything from quantum mechanics to consciousness. It's not just that math describes the universe, math is the universe.
And if it's wrong?
Then we learn something important about the limits of mathematical reasoning. But either way, frameworks like this push us to question our deepest assumptions about what's fundamental and what's emergent.
Well, that brings us to the end of today's deep dive into Ontology II. Whether this framework represents a revolution in physics or an elaborate mathematical mirage, it's forced us to think about reality in completely new ways. The predictions are testable, the math is intricate, and the implications are staggering. Thanks for joining us on Copilot Podcasts. And remember, the next time you look at a prime number, you might be looking at the building blocks of reality itself.